In my research, I took a neural network and taught it to predict the emotions humans experience from music. Then I asked it what made it make its decisions. I wanted to see if I could get a more empirical understanding of what affects our emotional experience of music. I designed a neural network that has all the components our brain uses to experience music. There's a convolutional component to hear the wave frequencies coming into our ears. There's a memory component for our memory, and a linear component for our other brain pathways. I wanted to keep the input of the machine as close to the human experience as possible, so I chose spectrograms. A spectrogram is a three-dimensional representation of audio where the x-axis is time, the y-axis is wave frequencies, and the z-axis is the strength of the signal. In this picture, for example, we can see 5 seconds of music as thousands of spectrograms, one after the other. Each spectrogram is for a short segment of the music. For emotions, I used a model suggested in 1989, which puts all emotions on a two-dimensional space. The x-axis represents valence, positive versus negative. The y-axis represents arousal, high versus low energy. So happiness would be high valence and high arousal, and sadness would be low valence and low arousal. After training it, the machine was able to predict emotions on short phrases of music 6 times better than random. I then fed the machine very simple audio clips and analyzed its response. For example, I fed it 25 seconds of the note A, 440 Hz, and turned off its memory. Unsurprisingly, it gave the same answer the whole time. But when I turned the memory back on, I noticed that the music got happier with time, and that it got bored and started lowering its happiness score after a while. So our machine had an attention span of around 8 seconds before it got bored. Another interesting thing was that the boredom came later when the machine heard a harmony rather than a single note, and it plateaued instead of dipping its score like it did with the single note. The machine also treated chromatic scales as annoying or agitating, just like humans do. This research could go in so many directions, but I just didn't have the time or resources to do it. All of the code is open source and shared on my GitHub, in case anyone wants to do anything with it. One other thing I developed was an emotional training tool for musicians. Basically, since the machine predicts the emotions humans would experience from a performance, we can give it a live feed, for example, me singing, and get live feedback about what kind of emotions our audience would experience from us. This is basically it in a nutshell. I hope you found it interesting. If you want to know more, I'll link my full research in the comments. And of course, feel free to ask me anything you want in the comments.